Hi, I'm Stephen Nixon. I run the Type Foundry Aero Type, where I release new typefaces and help other people to do the same. I'll be talking about shell scripting for font builds today, basically sharing my approach to build fonts in a way that I think is quite approachable, it's very scalable, and it's repeatable. So before I go further, I just want to say thanks to everyone who has worked really hard to put on TypeLab 2021 and typographics in general. It means a ton, and a lot of people get a lot out of it, so thank you. And then also, if you've come to see the talk, thanks for coming, and thanks for checking it out. So I've made a repo with some examples and a little bit of extra information. Some of the links I'll be sharing, it's github.com/aerotype/typelab2021 or typelab-2021. But I'll say that again when it's useful. So some disclaimers. This talk is Mac specific. It has some syntax probably that will work on a Mac, but not necessarily, say, Windows. A lot of the information will still hold, but I work on a Mac, so you'll see information around that. This is just one approach. It's mostly relevant to glyphs and UFO formats, though, for instance, you could work in FontLab and export to UFO and then use this approach. This is also pretty much about Python. The two are Python and shell scripts are quite intertwined when you're working on fonts often. And then I'm still learning. So the approach I show today, I don't think it's necessarily the perfect approach. It's just something that I've found to be quite useful and I think is worth learning. Even outside of fonts, shell scripting is a cool skill to have. So I've learned some of this approach and iterated on it through several projects of my own, as well as projects for others. These fonts that I'll use today were all projects of my own, some in collaboration with others. So Recursive, for instance, was my thesis at Type Media, and then Google Fonts commissioned me to finish and release it as an open source font. So that's great for this presentation because now I can use it as an example, for instance, for the build in the repo. Name Sans is kind of my current bigger project. It's about halfway finished and it's available through future fonts. And then Lang Syne is a brand new font that I'm about to release the initial version of. And this is actually the first time that I'm publicly revealing the name. So, you know, you've shown up to a groundbreaking talk here. So why? Why would you use code to build fonts? We already have existing, very easy to use graphic user interface tools as part of our font editors. And in fact, these are great. And if, for instance, you're more focused on drawing fonts and content to leave the technical details maybe down the road to somebody else, that's great. There's like infinite room to kind of learn and grow in multiple areas of type design. So I'm not saying that anybody has to learn this. I'm just saying that for me, learning about code and knowing how to build my fonts kind of from start to finish gives me more independence. And you know, independence is a bit of a fuzzy notion. Of course, this workflow still depends on the open source work of others in an ecosystem. And then at large in society, no one is completely independent. We all depend on one another for food, safety, roads, etc. So, you know, vote and pay your taxes. Thank you. So back to the talk here, building fonts with code is customizable. So you have really full control over what you make and how you make it. It's more repeatable, so you don't really have to remember too many steps because essentially you're writing everything down and programming it so that the computer will remember those steps. It's durable. Open source build tools are more future-proof, arguably, than closed source products. In a pre-built tool, it will be updated over time, and maybe it can be a little hard to like get a really old version. Say you make a font today and then you want to build it in 10 years. It might be very difficult to re-establish the exact environment to build that data. Whereas with open source build tools, things are set up so that you can get very specific versions of things and you sort of record the specific versions that you're using in this workflow. And then it's debuggable. So if you have a problem with your build, you can either dig into the underlying code yourself because it's open, or you can find other people who are familiar with it, and there are more of them because it's a bigger ecosystem than maybe the single creator or two of an app. So some useful definitions. Font building is pretty self-explanatory, but it's the process of creating type sources that you draw and then making them into working font files. So really something somebody could install. A terminal or shell or command line is a tool that lets you control a computer with code. Shell scripts are a script that allow you to program a series of shell commands. So not only can you control a computer one line at a time, as you might in a terminal, you can string a lot of lines together and then run them again in the future, so there's less to remember and it's more powerful. So to expand on this a little bit, shell scripting is pretty well supported. Most font dev tools, or lots of them, have CLIs or command line interfaces. Basically, they can be used in a terminal or shell scripts. It's helpful because you could remember the very specific terminal commands, or you could write them down and run them later in a shell script. It's powerful. As I've said, you can sequence tools and steps in this font build, and then it's pretty concise because you not only can coordinate those command line tools, you can also write Python scripts yourself to do specific things, or pull in Python scripts from others to do specific things, and even trigger other code entirely. And then I say it's concise because a shell script, since it's queuing a lot of other tools to work, you then get a pretty short, basically, series of build steps that you can look at. So what's in a build? Well, a typical build workflow might include preparation. You could take your working sources and maybe set info like version numbers or naming. You could remove draft glyphs, check for compatibility, etc., etc. There's obviously a build step where you build those sources into static or variable fonts. Maybe you fix some of the font data in that process. You organize things, sorting them into custom folder structures, maybe copying in a license or other docs. You test things, possibly with Font Bakery, to check for any errors that might be in your font data and disrupt its workability in various scenarios. And then there's proofing. So you're making PDF specimens, testing your fonts, checking the spacing and kerning, maybe seeing how they work on the web or in other desktop apps. So my typical approach is to split these things up. Basically, I use maybe a Python script for the first preparation step. I'll use shell scripts for usually building and organizing, but sometimes I'll split those up a little bit. I'll often just use the terminal for testing, and then I'll basically use the fonts in as many ways as possible to proof them. So not only making specific proofs, but also using them in generated websites or in Drawbacks or in keynote presentations for conferences. And this helps to find issues and fix them. So getting into a few details, kind of a tutorial section. Let's look at the anatomy of a terminal command. You've got the program that you're running. You can think of it as kind of like the app or the function that you're actually running. In this case, cd is to change directory. It's like changing from one folder location to another. Sort of, you can imagine if you're navigating in Finder, you're doing this by clicking. And then there's usually arguments, which are things that you feed the program to do it slightly differently. So often those will be placed, by the way, in like angle brackets or square brackets if you're looking up code documentation. So basic terminal commands, we just looked at cd. There's also mv for moving a file to another file path or like directory. cp is very similar. It's to copy a file. Echo is to print text to the output of the terminal, and that's really helpful, especially in like a shell script scenario. And then say is kind of like the fun version of echo. I don't tend to use it as much, but it will speak text aloud in a robot computer voice. So sometimes you need to know how a program works pretty frequently. So you might use man, which is actually a program itself, to show the manual, and then specifying the program that becomes really an argument that you're looking at, and it will give you this, this manual page. Checking a CLI's docs can be slightly different some of the time. So font make is a program used to build fonts. It's an open source Python project. And then -- help is what's called a flag, and it will show the docs from a CLI tool. And so, same thing really. So why is there a difference between man and help? I don't think there's a great reason. It's just sort of about the workflow of these things. Generally speaking, the basic and really old commands that have been around for a long time seem to use man, whereas newer programs seem to use -- help. And somebody with more historical experience might be able to tell you more. But flags, we just looked at -- help, and that's an example of a flag. It's kind of an optional thing that you can feed to a program. Often you'll add an additional argument after a flag, and then often flags will have abbreviations. So like just a single dash, and then usually the first letter or some similar letter. So let's look at a full command. We've again got the program and then flags, this time with arguments. So -m in font make says, I'm going to feed you the path of a design space. M is for multiple masters, I think. And then -o specifies the output. In this case, it would be a variable font. And so that's kind of can get to be a lot to remember if you've got different options for a script. So here's a very basic shell script, actually. The top line there just specifies the interpreter to use so that the syntax is predictable. And then this line is a variable. So here we're recording the file path as ds path. And then we can use that in our font make command. We just put a $sign in front of it. And I usually wrap it in quotes in case there are spaces. And then you see -o variable again. And then here we specified an output path to a specific folder and file name. So I could talk about syntax all day, but it might be a lot more useful to actually show the demo. So let's go over here. I'll actually open it in Safari, so you see a logged out version here. And let's look at this. If you're not super familiar with GitHub, I'll kind of go over it. This is a repo, or a place where a code project lives. These are the files in the repo, and this is kind of the note I added the last time I updated a file in one of these things. So, and then this shows how long ago that was. And here is kind of the README of the project. So this just kind of like tells you about the project and maybe gives you build instructions, which is what we'll look through next. So there's a basic setup here. If you haven't already done so, it's worth downloading the latest version of Python. So there's different ways to do this, but I find this to work pretty well. Go to python.org, downloads, and then this yellow button will kind of give you the right version of it. And then also important to this workflow is to install WAF2, which is a font compressor to make web fonts. So this is maintained by Google Fonts, and it will compress font files a lot. So if you haven't done that already, you can open a new terminal window and run the following lines. I've already done this, so you know what? I'll just try to do it again to be completist. So I open the Mac Terminal app, and you can use the Spotlight search if you want to do that. And then you can just copy and paste all of the lines at once if you want, all three of these, and then run it. And so this will kind of download and then build the WAF2 program. And then that allows you to use the command WAF2_compress with a font path, and it'll compress it. So it's kind of, downloading the things it requires, and boom, it's good. All right, so we'll close out of this window, and then we'll move on to installing this repo. So by the way, these are comments in a shell script, they start with a little octothorpe or hashtag, and they just kind of are a note of what's happening on usually the line below. So I'll copy this, and then once again, I'll open up a terminal, and I'm going to first change directory to desktop, then git clone the repo into this folder, and then cd into that folder. So it's downloading. Cool. And now my terminal tells me that I am, in fact, in this path. And if I want to see that in a more familiar layout, I can use open dot, which represents the current location, and see the folder in Finder here. See, these are all the files that conveniently match the files that are here. So next step is to set up a project environment. This is using a virtual environment. There's a lot that could be said about virtual environments, I'm sure, but essentially it just copies a version of Python and then sets up a little area for all of the current versions of the dependencies you have for a project. And this is kind of one of those things that enables you to have a predictable build in the long term. So it's very worth having from that front. Also, if you start installing a lot of things on your computer without virtual environments, in the past I've found that kind of messed up my computer a little bit. So it's very much worth using these. So I'll go back to the terminal, and you can do this with Python 3. This calls the venv module and then makes a folder called venv, just short for virtual environment. And then you have to activate it. So I'm going to copy and paste this. This says source and then points to a file that's actually in this venv folder that activates the virtual environment. So it's shown to us with parentheses, meaning that it is active. And then we want to install the requirements. And before I do this step, I will actually open this folder up in a code editor to sort of give you a better view of it. So this is Visual Studio Code. It's a nice open source code editor. Let's look at the requirements folder, or file, sorry. These are the requirements of this app. They're Python-based tools that are hosted online, and it's pretty amazing. Like, you can download these specific versions, and then you've got a lot of code that's pretty easy to use, and you didn't have to write almost any of it. Yeah, so when you're installing a requirements thing, that's what you're installing. And I'll also pop open the terminal here, which is built into VS Code, which is pretty cool. And I actually want to activate the, so I'm in the wrong virtual environment from before, so deactivated that one, and then is this still on my clipboard? No. Source venv bin activate. Cool. All right, so now we're in the right virtual environment, and we can even find that out by saying like which Python, and it gives me the full path to this current Python that it's using. All right, and then we'll install the dependencies. So there we go. And you'll see it processing. It looks like when we installed WAF2, it's collecting dependencies and their dependencies and their dependencies online and installing these things. And while that loads, we'll look at the next step. Right, finally we have to give build permission to the shell scripts that are in this example. So I'll kind of leave this loading here and show you what I mean by that. This is the basic shell script. It builds a variable font. This is similar. It builds a static font. And then this is a lot smaller. It just runs font bakery on a given font path. And when you say chmod plus x and then feed it this kind of wildcard, it's saying anything in this directory with sh extension will be given run permissions. And you kind of want to trust what is in a source or who you're getting it from, or just write it yourself, because otherwise people could potentially put malicious code in like a shell script. So I'll give it permission. I wrote it. I trust myself. If you want, you can go over it with a fine-tooth comb, but I won't be mining Bitcoin on your computer with these scripts. Okay, so the next step is, we've already done this setup, is simply to build. So I'm just reminding you that you always have to have that active virtual environment before you build, because we've installed the required versions there. And then to run a shell script, you simply feed its path into the terminal. So here I've done that, and it will build. So this build, to talk through it real quickly, basically it points to the DS path, sets some output paths that we want, and these are all variables. It preps the UFOs. There's a slightly different feature set that I want to use between variable and static fonts. So this is a Python script that I've written in build helpers to set code as it needs to be. So it basically just points to a different relative location for that code. And then this builds, it adds a directory if it's not already there. And then this is the font make line, kind of the critical line for building a variable font. And then I want to apply a few fixes. So this uses a Python script to add a stat table. This kind of fixes non-hinting, which can be a problem. This adds a family name suffix, in this case TL21. So if you install this example to try it out, it won't clash with your existing installation of recursive or your future installation of recursive. And then a full build would actually have more of these steps, usually prompted by like warnings or messages from Font Bakery or other QA work that you're doing. And then finally, we want to make a web font. So this is that WAF2 compress system that we just installed. It'll make a web directory and build it, and then it copies in the license and does this. And then I won't actually run the build statics file. It takes a little longer, and I'm running a little short on time here. But it is very similar, but just does things a little differently. So for instance, it runs a loop to loop through and fix all of the built static fonts. And then similarly, it runs a loop to build the web fonts. Yeah, and then I will quickly show you this check file because it's very quick. Basically, I can copy this path, and then I can point to one of the fonts we just made. So I'll point to the variable font. And this just shows you how Font Bakery works. So it goes through a font and tells me things like, about like specific data tables that it expects to see in a font, or maybe like if it expects a slightly different kind of metrics to be in the fonts. Here's a good one. It expects a different Panos value. So you can see, by the way, that this is a very short shell script. And in fact, I usually just type this myself because it's almost as quick as like pointing to the path of the shell script, and easy enough to remember for me. But it's still helpful to do this sometimes if you're not yet familiar with a script. So getting back to the presentation, just to kind of round this off, there are a few drawbacks to shell scripting, and you might have kind of gotten a sense for that as we were going through it. But the syntax can sometimes be pretty picky, and some things require trial and error or Googling. That's the case in basically any coding that you're doing, but in shell scripts, there's a few specific difficulties. Like I think there's a difference between single and double quotes and how they act, which isn't really a difference in most languages. It's semi-repetitive, so you could see maybe that I was like splitting up my variable for my static build, and that's the convenient way to do it there, but there is some repetition in code, and maybe you don't want that. Or if you're really using certain scripts a lot, like it's maybe tends to be more useful to do Python packages, sort of like GF tools, and you could kind of go for a full Python build, or you could have kind of a hybrid build as I'm doing. And it can be a little inflexible. So I think that shell scripts are best when they're kind of kept concise and high level, and they're mostly like saying what other tools to use. and then it ends up being something that you can read fairly quickly and understand what's happening. So an unscientific chart here, just to kind of like visually explain this. Shell scripting starts out as pretty easy in a low complexity project, and then maybe it gets like somewhat harder and quite a bit harder when the complexity increases. A value of Python is that I think it's a little bit harder to get started with, but it does better with more complexity. And then the thing that I'm really tend to avoid, and really the point of learning these programming languages, is that editor exports and pre-built tools that are offered by other people are very useful, especially in a low complexity project. If you're doing essentially what they expect most fonts to be, then it's all gravy. But at some point you hit a wall, basically, where you can't use that tool to do what you need to do. And then there's no ease in that. So that's when you want to maybe transition to shell scripting or Python. At the end of the day, shell scripting is useful and approachable, and I think it's worth learning. So if you want to learn more, these links are also in the repo, and it points to a few useful resources. Yeah, here's that repo in case you want to get it one final time. I'm Type. Thanks so much for listening, and I hope something here was helpful for you. Let me know if you have any questions. You can reach out to me on Twitter, Instagram, my website, whatever. Thanks. Have a good one.